DG is first.
I got cups next. Don't worry about it. I got you.
Hello. Okay, so our next talk is by Vyrus and Frank, and it's called My Other Shellcode is the Da Vinci Virus. And if anybody knows me, they'll know this is a topic very near and dear to my heart.
Hi everybody. Okay, this is a good place. So yeah, this is Vyrus and I's talk. It's basically just before I begin, if you don't like wieners or titties or any of those things, also if you're offended by me even saying those things, you probably shouldn't be here.
Pshaw!
Yeah, see, that's what I'm talking about. That's what I'm talking about. Yeah, so there's going to be gratuitous use. Oh, how many people are familiar with last measure? Yeah, it's going to show up. Yeah.
This talk contains dicks everywhere.
Yeah, like as Vyrus just said, this talk contains dicks everywhere. Huh?
Also cocks?
Also cocks. Also cocks. So yeah, let's get started with this. Vyrus, do you want to?
Oh,
Yeah.
okay.
Yeah. Well, actually, yeah, no, I can do this part. Yeah, I'll just do the first part. So, thank you very much. I need this. Social lubricant. So I mean, let's get started. So I mean, what exactly is shellcode? I mean, shellcode is ultimately just a long string of instructions that you want something to do. Like most of the time it's assembly. It's not always assembly, most of the time it's assembly. A shellcode is ultimately a payload, and I mean, when you're doing an exploit and when you're exploiting code, the exploit needs to do a thing. You can't just be like, I'm going to throw stuff at it and things are going to happen. No, that's not usually how it works. You actually have to tell it what to do. So shellcode is basically how you actually accomplish that. So it's even though people will consider us, computer wizards because we can write move instructions and things like that, it's not all magic and dragons. As cool as that would be, I would really, really like it if it was actually just wizards and dragons and shit, because that would be really cool, but that's unfortunately not what it is. So, yeah, every operating system basically is different in how you can actually write shellcode for it, because they're all their own little islands of clusterfucks in itself. I mean, Linux is just an open source circle jerk doing all sorts of different things. OS X is just kind of, the hipsters in paradise making their own operating system. And Windows is just, have you ever gotten spaghetti that doesn't really have sauce on it, but they just threw on a bunch of noodles on your plate and you're pissed off because, you wanted some sauce with your spaghetti as well, but it's all noodles and you can't even get the noodles out because all the noodles are tied up together. You can't even get your fork in there. You try to, and then it just cuts up the noodles, and it's just absolutely. That's kind of how Windows works. So, yeah. So all the different operating systems are really different in how you can actually accomplish writing shellcode for them. So let's start with Linux.
So Linux shellcode, so the easiest way to tell a payload on Linux or any Unix-based kernel operating system to do anything is to just call the kernel directly, because the way that the ELF binary setup is constructed, the kernel has all of these things in it that will do stuff for you when you call stuff. So you don't have in Windows, as Frank will talk about later on. There's a lot of library hooking, and this computer's totally useless unless I can hook this library to do some other stuff, and oh my god, I only have kernel access, what am I going to do? Or I only have central access, what am I going to do? So in Linux, that's not how it works. In Linux, you have the kernel, and if you own something, you just go, okay, well, if I want to download a file or I want to drop an interface, the kernel has that functionality in it. So you're just writing syshooks. So here's an example of Linux shellcode. I could go through it line by line, but there's really no point in doing that because the purpose of this talk is not to show necessarily 100% how shellcode works, but simply to say that shellcode used to be cool, and then a bunch of boring Chinese assholes decided they would just steal credit card numbers forever, and then it got really boring. So fuck that, we want to do cool shit. Because I don't know about you guys, but like, there's a virus out there that its whole job is to display a tiny checkbox. It's about yay big, and it's made by a fan of the boxer Manny Pacquiao. And when you get the virus, it goes off, I think, at 6 o'clock every day for a week after you get infected, and it displays a checkbox that says, "Long live the Filipino people," with a P, and Manny Pacquiao's awesome. Coolest virus, period. Right? Credit card numbers, bitcoins, fuck that. So the major things to take away from the slide are basically, so you push a bunch of arguments, the arguments go into place, and then you call syscall, and syscall calls whatever sys instruction you're going to call. So there you go, basic Linux shellcode example. That's what it would look like in C. So basically, if you have opposable thumbs and you can Google the syscall list, and you can look up the list of functions that can call by xsave, congratulations, you can write shellcode. Not that hard. You can totally be that guy. So there's more stuff in there than xsave, but all of it's, most of it's well documented and boring. So yeah, Google it, and you will be that awesome. And BSD and OS X essentially work the same way because the kernels are based on the same topology. So for the most part, if you have syscalls, you have bugs. The only real lynch is that on BSD the syscalls are slightly different. On OS X, they keep engineering the kernel to include less and less syscalls because they, for lack of more explanation, built their own little pool inside the OS X kernel where only they can play, and they like keeping all of the fancy functionality that's kernel based inside that pool. That way they don't have to give it to other people. That way they can use it to exploit your machine. But there's a way around trying to use their syscalls, and that way around is using Cocoa. So the way Cocoa works is it's kind of like hipster.net, right? So anybody who's ever looked at .NET, right? It's not really a VM. It's kind of like a big DLL, and you call it and say, I would like to call this .NET universe, and this DLL constructs this big fake universe, all these fake functions, these fake callbacks, and these fake processor instructions, and then you tell it what you want it to do, and all of that sits in this kind of virtual bubble. That's basically how Cocoa works, only it's easier to track than .NET, which is cool. Unfortunately, it's also what Apple uses to write their programs in. It's kind of like the Apple version of libc, or of WinLib, I think it's called. Whatever the Windows standard. What's the Windows standard library in called? Yeah, MSVCRT. It's basically the OS X version of that. So they put shit in it to fuck with you. So like if you call a function in the wrong order, or if you call a function outside your security group, it won't necessarily give you an error message. It'll stop working and fuck your machine. Guess how I learned that one. So Apple limits syscalls because they try to use Cocoa instead, and this can be good because everything is in one place. You have one hook to attack. If you have that hook, then you can call any Cocoa function. But it's bad because it's all in one pond, and Apple can piss in your pool, and nobody likes to drink piss. So there's one interface to Cocoa, and that interface is called send message. That is the object send message point interface in Cocoa. It's one function. So everything that you do in Cocoa means you send the send message mcall a string, and then you send it a bunch of strings, 2 arguments. The bunch of string argument is all of the arguments you're passing to a function. The first string is the name of the function. So if you have this one function call, after you exploit software, if you have the link to sendmessage.m, you can call any function inside Cocoa in the context of that application, period. Which means you can write shellcode that does all kinds of awesome shit as long as you call it in Cocoa first, which is well documented and designed for people to write software for it. So why dick around in fucking syscall land with, assembly and math and nerddom when you can just use the documented functions in Xcode? You can literally use Xcode to write shellcode on Apple. That would be the function. So at first I was like, yeah, because this is how, if we were reversing this and looking for a bug. So you see this push D word down here after the location? Where's the mouse? The mouse is gone. I have no mouse. There it is. See this? Okay. So this is it pushing a string. This string is the name of the function, right? This argument tap is all of the arguments that go to that function. And then it calls send message. That's how it works. It's pretty simple. So it can make things hard to reverse at first by default, but since the stuff is always in the same place, once you have the first offset of the program that you're attacking, you don't have to do any more shifts. It's kind of like ROP. It means once you own it, nothing moves around in stack. Drink again. It means you don't have to debug a lot. So this is a commented version of source from the same application. So you can see all the arrows are to the comments of those are what the strings are in the offset. So those are the functions that are getting called, and those are the arguments that are getting passed in order. So once you know where it is, it's pretty easy to reverse. Then Lion came out, and they fucked with it. So with Lion, what used to be this, wrong slide. Where'd it go? Did I miss a slide? Yeah, I missed a slide. Okay. So what used to be this, now you don't get any of those comments anymore. You don't get any of the taglines. You just get an offset. And that offset is mutated by a key. And that key has two in factors. One of them is a hardware key, which is different in every single person's device. This works on iOS and any of the desktop systems. So it's hardware based. It pulls from an ID and a chip. And I don't know which one, so good luck trying to get me to drink it out of me. And the second key is dynamically instantiated on boot from the first key. So unless you have both keys in context, which are outside the realm of the current user, you have no idea what this shit is, which means the offsets don't make sense, which means you can't call anything. Fuck it. But it's still broken. So even though they moved the sandbox, everything has to be able to reach sendMessage.m in the same context in order for it to work. Which means if you have the distance between sendMessage.m and the beginning of your program, you have the offset you need, which is always EIP when you break the program. So I did have a demo and was going to show non-obfuscated shellcode that used Cocoa to be non-mutationable, but I wanted to see if it would work in Lion, so I had to upgrade my machine to Lion, and it broke. And then I found out that if you trace sendMessage.m in real time, the sandbox bug goes away. Unfortunately, that means I broke my shellcode. So I don't have a demo, but instead I used the same trick to deobfuscate a function in a closed source application, which I didn't put in the slide because I was trying to be polite to the company, but seeing as how it's public information, I kind of don't care. So there's a company called SoThink that makes a SWF decompiler. And this is, if you look at the sendMessage.m call to end string, this is where all of the strings are in the program that don't show up when you debug it by default. This is the blacklist of email addresses that when you go to register the program, if you type in one of these email addresses to register a key, it'll go, no, fuck you very much. So the funny thing about this blacklist is the guy at the top, if you Google that email address, the very first Google link is his website, and his website has his resume on it, which has his phone number on it. And I was in Seattle when I found this, so I called him. I still haven't gotten an answer back, but whoever this person is, there are 6 different functions. 2 of them are only for this person to check the blacklist. So I don't know what they did to piss off SoThink, but they really don't like that guy. The other funny thing in this blacklist is that the list at the bottom starts listing TLD names with asterisks, and almost all of them are in there if you try to register with an asterisk name, except for one. What the fuck happened? What'd your computer do?
Shellcode.
That guy in Seattle.
There we go.
That's the bottom of the blacklist. Apparently the feds like Waresing software. I have no idea who Sandia.gov is or who that person is, but apparently SoThink caught them trying to steal their code, and they said that's fucked up.
It's a major research lab.
All right, my turn. So, I mean, with Linux and OS X, you're usually limited to like syscalls unless you want to do crazy things like, I'm going to load these .so libraries, but I don't know where they are because every single sysadmin does their own thing and they're really grumpy about where they put their things. So I'm just not going. So that's why most people use syscalls, mostly because Unix beards are very aggressive. But if you compare Linux and OS X to Windows, Windows is a fucking Cadillac of just everything you can do. Because like Linux is like, nah, we're just gonna provide the kernel, and you guys can do your thing. So that's why your video card stuff and your audio stuff in Linux sucks, because everybody's fighting to be that guy who does the audio stuff, and everybody's fighting to be that guy that does really cool video card stuff. Anyway, that's. And Intel and NVIDIA fight dirty. That's a good way of putting it. But I mean, with Windows is like, yeah, you can have this text-to-speech API. You can download stuff from the internet from Windows. You can play MP3s. You can do everything for only $99. So I mean, if you really want to use syscalls in Windows, sure, you can do that. You can simulate KI-fast system call red or whatever the hell that function name is, or you can just use the API. And seriously, Windows is awesome. As ridiculous as the structure is, and having to deal with all the stupid pointers that go everywhere, and like all the reserved values, and like the documentation is really cool. Like, don't get me wrong, like the MSDN is really awesome, and there's like everything is in Windows. Like that's why it's so ridiculously huge. But that also means you can do everything. It's awesome. So, but there is one caveat to the fact that everything is in it. With Linux shellcode, you've got syscalls, and it's like, I'm going to Google syscalls. I like that syscall. I'm going to call that syscall. So the complicated thing is when you actually have an exploitable program in Windows, they can import any API they want. And that means that there isn't really a predictable, unless you know the program you're targeting, you know that, okay, I know this DLL is in there and this DLL is in there. But I mean, what if you want to reuse your shellcode? I mean, what if you want this shit to actually be reliable instead of targeting just one program? You don't want to rewrite your shellcode every single time. So, I mean, what you have to do is you have to assume that your libraries aren't going to be there. The only, in Windows, because of legacy reasons, this is actually pretty funny. In Windows 2000, it used to be an error for a program not to import kernel 32. And it would just be like, no, I'm not loading that. You're not importing kernel 32. I guess people got grumpy at this because after a while, like Microsoft implemented a hack that was like, all right, so every single program ever has to load NTDLL, which by the way has kernel 32 as a dependency. What? So now every single program after XP automatically imports ntdll.dll and kernel 32.dll. But here's the thing, like if you want to get any other function. Oh yeah, that's awesome. So apparently that also helped make Metasploit smaller, so that helped out those guys. So I mean, the issue is you have to assume that there aren't any libraries loaded if you want to have reliable shellcode. But in order to get a function, you need to find a library. In order to load a library that's not there, it might be there, it might not be there. You don't fucking know. You're shellcode. So you have to actually get load library. And in order to find load library, you need to get kernel 32. And in order to get kernel 32, you need to grab the loaded image. In order to find the loaded image, it just becomes a whole clusterfuck, because then you have to automatically load the PEB and then scroll through the PEB to find if the module is even in there. It just becomes a rat's nest immediately. So, like I was saying, you're only really guaranteed the NTDLL and kernel 32. Oh, I just said all these slides. Oh yeah, maybe if you're on a Kazakh, because there's also other issues regardless of the fact that you don't know if they're libraries. I mean, you can't, like, what if you just want to say, okay, well, I know this is going to be loaded, I'm just going to make this the address. Well, the way DLLs work, they can be any base address they want to be. There's, like, it's not that there's ASLR, sure, but I mean, with DLLs, I mean, if there's an address collision, the loader will just be like, oh, I'm just going to move this shit over here. And you have to deal with that. That's why you have to use load library and get proc address, because the shit can just change around. And it's different from language to language, too. I mean, the Kazakhstani XP might have a different thing for user 32 than the Italian XP, and now you can't actually use the function, so now you have to deal with all. So you have to assume that nothing is hard-coded and you can't really do anything. And it's kind of irritating, but that's also kind of why it's fun. So, I mean, this is also a really interesting contrast. On average, reliable Linux shellcode to just spawn like binsh or something like that.
Unless it's designed to be 64-bit and
Yeah, unless it's designed to do all sorts of things like 64-bit, NX stack, things like that. On average, it's about 50 or 70 bytes. So it's not a lot of instructions. On Windows, because you have to do all this ridiculous loader stuff to have really awesome, reliable shellcode, it's like on average like 200 bytes. That's a lot of shit. Oh, okay, now here's the fun part of the talk. So I actually have some payloads that work, like a bunch of them use the internet, so they probably won't work. But there's two other ones that are fun. Yeah, so Vyrus is going to set up the internet for me, and I'm going to set up the VM for a bit. Okay, cool. Okay. Yeah, I need it. All right. Oh, since this is up on my VM, this is one of the payloads I will not be showing because I was debugging it and it was too complicated. You'll notice in the title for OllyDBG it was called Dick Parade. So I can't show it because it's really buggy, but we're going to have contact information at the end, and I'm going to release this. So what Dick Parade is going to do is once it runs on the system, it's going to inject a thread in every single running process with an infinite loop for message box. It's just an ASCII penis. So every single process will be running an infinite loop of wangs. So it's a Dick Parade. Resize. There we go. Let's see here. All right, let's start with an offline one. I copied you, didn't I? Yes. Yeah. All right, so in order to show these off, I didn't have an exploitable program, but I have the assembly compiled down and then converted to an exe. So what you're seeing here is basically the shellcode running as if it were executing normally. It's just running itself in an exe. So let's run Batman. So here's a folder named Na on the desktop. Which apparently, oh no, it's cool. It'll work on it'll work on 7. But let's see. Aw. All right, this will work on 7. Give me just a moment. Let's see. Pretty much. See, this is why CP said you record stuff, because this always happens. Always happens. I don't learn my lesson, though. Pretty much. All right.
So this isn't really the computer failing, it's just other substances killing brain cells.
Yeah, so this, unfortunately, in testing, worked. Did not in demo, because demo gods hate me. So I'm going to test this and republish it. I'm so sorry. I feel like a jackass. So what this wound up doing, a loop of 16, create directory, na 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 Batman. All right, now one that works. So
This one's more awesome.
yeah. No, Dick Parade won't work. I'm sorry.
It's definitely
All right, so we have internet. Hopefully less measurable work. Of course it doesn't. Yeah, this is sad. I'm sorry.
For the demo gods.
Yeah, thank you for the demo gods. So let's see if we can get one working. That's what I'm really curious about. This is embarrassing. What else do I have here? Oh, this one works. Let's see, debuggers. So Russian roulette is a shellcode that basically enumerates a bunch of processes on the system and just kills one at random. So it could kill itself, or it could kill something really important. So let's see what happens when it doesn't work. Yeah, check that out. Access violation. That's not working at all. All right, so we're 0 for 3. Oh, God. I don't, oh, wait, I got something. Turning it off and on is a good idea. So let's see, what else do we got here?
Let's measure. Can't remember what the other ones were.
You could just run Batman at this point.
I could.
Or Dick Parade.
What else do I got? Let's measure. Are we all for 4? Oh. All right. Let's try this one. Downloads and plays a random an MP3 from the internet. I hope you work. No, it's not a hard-coded Rickroll. It's something else. It's creepier. All right, so let's wait for this thing to actually download the MP3. Seems to be working. Oh, it's downloading? Cool. All right, so this one might actually work. Hopefully it actually plays the MP3. So I'm going to go load the other one. Huh? Well, yeah, when the MP3 plays, because it'll take a bit. Is it still downloading? Okay, cool. So I'm going to launch the other one. There we go.
Start with a C, start with a G, start with a C, nothing nasty now.
San Francisco Rush, anybody? No one? Aw. Yay! All right, 1 for 4. Let's go for one more. I want to see some titties in this thing. Hang on. Hopefully titties. So this is called Chinese Wiener Trap. Downloading?
Yes.
Okay. Oh, there we go. Chinese Wiener Trap. Hey, I told you, dicks everywhere. You had fair warning. Her name is China, by the way, hence Chinese Wiener Trap. Oh, nice. Nice. Nah, I just pulled out. Alright, so 2 for 5, that's not bad, it still sucks. So, like I was saying earlier, the caveats with this, obviously when you don't test properly, the demo gods just stick their dick in you, so, you know, that kind of happened. I'm sorry about that. So I'm going to test that and publish it eventually. Sorry about that. I tried to have a dick parade ready and I told you about why. Like, the main reason for that is when you try to open a remote process in Windows and try to actually read a bunch of data, like you would think that, okay, I'm going to go see which DLLs are loaded in this remote process. It's not that simple at all, actually. It's fucking retarded. Because you have to, like, okay, I have to do NT query information process, and then I have to get the PEB, and then, oh, I can't actually read the pointer that's at the PEB, so I have to use read process memory to get that pointer. And there's another pointer I have to read process memory, and then there's another pointer, and then you have a linked list of pointers you have to keep doing read process memory with, and it's fucking irritating. But yeah, it'll happen eventually. And yeah, pretty much pointer math. So the dick parade did not happen. At least there was at least 1 dick and 2 tits, so I mean, like, it all averages out.
The bottom line is the 2 payloads that went off were really cool to use on your coworkers at work.
Yeah, exactly. That's a good point. The bottom line is the ones that did work are actually really funny to use on your coworkers. And you can use any MP3 or any picture you want. So, yeah. So with Windows shellcoding, you know, the whole API is there, but I mean, once you start doing really more complicated stuff, another one that, you know, we really wanted to do, obviously, was Cookie Monster. But at the point of trying to make Cookie Monster happen, it becomes a virus because you have so much code that you have to write that it just becomes absolutely ridiculous. Because, you know, you have to do, okay, I have to create a window, and now I have to move that window around. In order to create a window, you have to have a window function that tells it, okay, well, when it moves or when it does this, you have to, and there's all sorts of different shit you have to do. Sure, you could do it as shellcode, but I mean, it would be so inflated, there would be no point anymore. What was my...
Also, screen math on Linux is a bitch.
Also, screen math on Linux is a bitch. So, I mean, and also, there's another one of the caveats is that, fun stuff is a little harder to do on Linux and BSD because you have the whole, it's like, I don't know if libxml is going to be there. Maybe it'll be there. I don't know. I'll look for it. But if it's not there, then it's not any fun. And I mean, there's all sorts of, because I mean, you got the whole land of just open source, and it's just, kind of a difficult thing. But I mean, it's not impossible to do fun stuff. I mean, a bunch of my friends are doing fun, ridiculous things with BSD and Linux shellcode all the time. I mean, Datagram, I know he does stupid shit. Come on. Where are you? Come on, man. Nowhere? Aw. Well, Datagram is pretty awesome at this stuff too, hence why, he gave the intro saying, this is really close to his heart. So this is our contact info. If you want to yell at us for the fact that my demos didn't fucking work, that's cool, because I totally deserve that. So I mean, I'm going to eventually post these. Obviously, I have some shit to fix. So yeah, there's that to deal with. And the dick parade will happen. I know exactly how to fix the issue and how to actually deal with everything. And hopefully there will be music that goes along with the dick parade as well. Oh, and the Cocoa version. Yeah, that's going to happen too. So that's all. Thank you very much. Yeah. Does anybody have any questions? No questions? All right, cool. Okay. Oh, CP.
Why is there no dick parade?
Why is there no dick parade? Well, I'm a procrastinating motherfucker, for one. Two. The difficulties of actually performing a dick parade were a lot more complicated than I had originally thought.
I've been in several, and it's not that hard.
Oh, okay. I guess I just don't have enough.
Then you were doing it wrong. We're going right now, is what I'm saying.
Well, I guess I just don't have as much experience in dick parades as most people do. So I mean, I appreciate your input. Thank you very much.
It's not hard. You're not doing it right anyway.
That's true. Dicks really do need to be hard. Yeah, it's Datagram. All right, is that all? All right, cool. Thanks for letting me talk, guys. Or letting us talk, sorry.